relative yield. The better fertiliser decision cropping, start again. The better fertiliser decision cropping interrogator is based on the results of 5,000 trials from central Queensland through New South Wales, Victoria, Tasmania, across through South Australia and West Australia. So we have a large number of climate zones there, large number of different soil types and textures, different moisture holding capacities before and during the season, different in-season rainfall, different temperatures at the end during maturation of the crops that are in the interrogator, which are cereals, oilseeds and pulses. So with all that data, that you would expect large variations in yield and yield response to the same rates of fertiliser being used in different places, and that's exactly what occurred. So to make sense of all that data, 5,000 data sets, they've used relative yield. Now relative yield is the yield of the lowest yielding, start again. Now relative yield is the yield of the crop without the applied nutrient versus the yield of the crop that is not lacking the nutrient. So it's the minimum yield over the maximum yield. The minimum yield without any applied nutrient that you're looking at, which might be phosphorus, versus the maximum yield that was obtained with no limiting nutrient. And we're looking at percentage, so it's relative yield percentage, multiply this by 100%. Now in this example over here, we have got 14 trial sites, 1 to 14. We've got soil test values ranging from 3 up to 25. Now this could be cobble P, milligrams per kilogram. It doesn't say what it is, it's just an example. And we've got maximum and minimum yields for the 14 trial sites, ranging from about 1.4 tonnes per hectare up to about 3.5 tonnes per hectare. So over 14 different soil types, climate ranges, we've got this range. So rather than, the better fertiliser decisions interrogator, you can look at yield increase, but we're better off to look at the relative yield, and that's what we're going to do here. So the relative yield is why the yield without the nutrient versus the yield with the nutrient not limiting. So in this case here, a soil test value of 20, we've got 2.6 assumed tonnes per hectare for both, so 2.6 over 2.6 by 100 is 100%. Now in trial site 2, the minimum yield was 1.4 tonnes per hectare and the maximum was 2.4, so it's just a matter of going 1.4 divided by 2.4 as a percent, 58%. For trial site 3, soil test value was 11, so it's moderate, I guess you could say, and a yield of 2.6 tonnes per hectare without any applied nutrient, divided by 3.2 tonnes with the nutrient, or 81%. And trial site 4, which only had a soil test value of 3, so pretty low by any nutrient standards. The yield without so you expect this to be quite a responsive site, and the yield without any fertiliser was 1.6 divided by the yield with fertiliser, maximum yield 4.1. So in that case there, a relative yield of 39%. So they could say that they got 2.5 times the yield by applying the rate of fertiliser there. So we continue doing that for the 14 sites, and we end up with the relative yields for the 14 sites. Some of them are at 100, and some of them are down. The lowest one was 39 at that site 4, 39%. Okay, now what we want to do is graph this information. We want to graph the relative yield against the soil test value.